Okay, I'm having a look at question 4 from our Maths Methods Unit 4 revision quiz. So we've got, it has been found that in the past 4% of the CDs produced in a factory are defective. A sample of 10 CDs is drawn randomly from each hour of production and the number of defective CDs is noted. What percentage of these hourly samples would contain at least 2 defective CDs? So we're looking at a binomial type situation where we have, they are either non-defective or defective. We have a set number of trials and we have a probability that they are defective. So we've got our n is equal to 10. We've got our probability is equal to 0.04 because that's 4% is a decimal. And we're looking at what the probability of at least 2. So that's where x is greater than or equal to 2. Now, when we use our calculator with the cumulative function, we need to, it will add up from the bottom to a certain point. So we can't put in the 2 and higher, but what we can do is 1 or lower. So we can get it to add up to 1 because 1 is the number directly below 2. So we can get it to work that out, and we know that that will be the opposite of 2 or more, so we know that that will equal 1 take away the probability that x is less than or equal to 1. So we grab our calculator, we're going to pop that in there to our second vase, go to our binomial CDF, and we're putting in there our 10 trials, our 0.04, and we're wanting it to add up to 1. And then we press enter and we get 0.9415. Now remembering that we need to do 1 take away that, so we get 0.058 for that answer. Now it's asked for what percentage, so we need to change that to a percentage, which would give us 5.8%. So that would mean about 5.8% of those samples would contain at least 2 defective CDs. The next part of the question asks us to find the mean and the standard deviation for the CDs of the number of CDs in the sample. So our mean is going to equal NP. So we've got 10 times 0.04. So our mean would be 0.4 CDs being defective. To work out our standard deviation, we need to do the variance first, and our variance is equal to NP outside of 1 take P. So we would have the 10 times 0.04 multiplied by 0.96. So when we do that, we get 0.384 for our variance. Now our standard deviation is the square root of that. So when we do the square root of that, we get 0.619 or approximately 0.62. Then the last part of the question says a particular sample is found to have 3 defective, I think I missed a part of this one. I needed to calculate the mean plus or minus 2 times the standard deviation. So I'm going to be doing the 0.4 plus or minus 2 lots of 0.62 there. So we would get our 0.4 plus 1.24 and 0.4 minus 1.24 there. So finishing off that question. A particular sample, so doing part C now, is found to have 3 defective CDs. Would this cause doubts about the population process? So we want to work out what's the probability of that happening. So when we do our what is the probability that you do a sample and you get 3 defective CDs? So we're doing like we did in part A of finding out of those 10 samples with our probability of 0.04, what is that probability of getting 3 defective CDs? So we're going to use our Binom PDF this time. So up here we were using our Binom CDF. To do that, here we're doing our Binom PDF. So we'll do our second vase, scrolling up to get our Binom PDF. Our number of trials is 10, our probability is 0.04, and we're looking at what's the probability of getting 3. Now we get 0.00577. So if we multiply that by 100, that tells us that the probability of that happening is 0.577%, or about 0.6 6% of that happening. So that would be a concern. That you are getting that number of defective CDs when the chances of that happening are very low. So we're not talking 6%, we're talking 0.6%. So that is quite low. So that would cause a concern with the production process.